To this just won't work. Let us do some practice questions. Okay. It says find 5 equal fractions of each of the following. We can use any method that we want, either multiplication or we can work with division. Or if you want, you can even work with the making of all those diagrams to get that. Okay, all on you. So I like the method of multiplication and division, so I'll be working that. I won't be drawing anything here. So working with 2 over 3, let's multiply both these numbers, say by 2. We never multiply a number by 1 and 1. Why? Because it will give the same fraction, so it won't make any difference. So for the equal fraction, you must at least use the number 2, 3, 4 and so on. You can make infinite equivalent fractions to a particular fraction. Okay. So the first fraction that comes out to be is 4 over 6. This is the first one. Then we have to make 5. Now think about multiplying 2 over 3 by 3. So it's 6 over 9. This is our second fraction. Now multiplying 2 over 3 by 4. So 2 times 4 is, now here I have worked it out. We can directly just think it in our head so that we make quick calculations. So what is, now I am multiplying each of these numbers, the numerator and the denominator, by 4. So what is 4 times 2? It is 8. What is 4 times 3? It is 12. So this is our third fraction that is equivalent. Now let's multiply 2 over 3 with 5. So what is 5 times 2? It is 10. What is 5 times 3? It is 15. So this is our fourth equivalent fraction. Now the last one, let us multiply them by 6. What is 6 times 2? It is 12. And what is 6 times 3? It is 18. So this comes out to be the fifth equivalent fraction. So can you just say what all fractions are equivalent to 2 over 3? It is 6 over 4. It is 6 by 9, 8 by 12, 10 by 15 and 12 by 18. I hope this is clear. Let's move to the next one. Here again we are going to write the equivalent fractions to 1 over 7. If you are asked to show the steps to do your work, you must write exactly this way. Okay? If you want to just write directly, it's all upon you, but make sure that you always give a good reason to your answer. So explaining your steps is always advisable. Now here it's 1 over 7. So 1 over 7, we can multiply these with any number of our choice. So say I'm multiplying them both by 5. So this comes out to be 5 over 35. Okay. Now I'm multiplying 1 over 7 by 2. So it is 2 over 14. Now I'm multiplying it by 3. So it is 3 over 21. Now let's multiply it by 4. So it is 4 over 28. Now 1, 2, 3, 4. Let's multiply them by 10. So it is 10 over 70. So all these that you see, 5 over 35, 2 over 14, 3 over 21, 4 over 25, 8 and 10 over 70, they are all equivalent fractions. Okay. You can multiply by any number of your choice. You can multiply it by 10, 100, 1000, 10,000, all are correct. Now try with this one. It's 3 over 5. Let us multiply it by 100. So the equivalent fraction is 300 over 500. Let me multiply it by 10. So it is 30 over 50. I'm going to multiply it by 1000. So it is 3000 over 5000. I'm going to multiply it by 10,000. So it is 30,000 over 50,000. Okay. So now let me multiply it by 2. So it is 6 over 10. So do you see how much different all these numbers look from each other? But still they are all equivalent. It's really fun. You can make as big number as you want. You can make as small number as you want. It's just having little fun with the numbers. So you can just try with any number of your choice. The last one let's do here to work with the equivalent fractions to 5 over 9. So multiplying it by 2, let's start. So it is 10 over 18. Let's multiply it by 3. So it is 15 over 27. Now multiplying this by 4, so it will be 20 over 36. Multiplying it by 10, so it's 50 over 90. Multiplying it by 100, it is 500 over 900. So these are all 5 equal fractions to 5 over 9. Okay, I hope you have understood this well. Moving ahead, here it says that find equivalent fraction 2 over 5 with the numerator 6. Clearly we are mentioned 2 over 6. So look how you should write it so that you have a clear picture. 2 over 5 needs to be multiplied by something. So I'm just putting a boxes here so that I get 6 as the numerator and I need to find the denominator as well. So these 3 boxes needs to be filled and we are just given 2 over 5 as the fraction from which we are going to start, and at the end we should end up having 6 as the numerator. Okay, so think about your 2 times table. 2 times what number will give you 6? I hope you know the answer is 3. So if we multiply numerator by 3, we must multiply the denominator by 3 as well. So here also you will have 3. So the answer will be 6 over 15. Is this clear? How did we do? We simply thought that what times by 2 will give the answer as 6 because that is the numerator mentioned here. So it is simple, it is 3, and we do the same with the denominator. So we got the answer as 6 over 15. I hope this is clear. Now let's find the equivalent fraction of 15 over 35 with denominator 7. Let us write it again in the same way. 15 over 35, and here we need to do something and put some numbers here in the boxes so that we get the denominator as 7 and we don't know what comes here as the numerator. Now point 1. Do you see the number when we are given that after the equals to sign, is it getting bigger or is it getting smaller? From 35, it is getting smaller to 7. What does this mean? If we multiply a number, it becomes bigger. If we divide a number, it becomes smaller. So that means the first thing we are going to notice is we are going to divide this 35 with a particular number so that we get the answer 7. Okay, now think about your 35, like in what times table do you know that you get, if you have to divide it by 35, if you divide that particular if you divide 35 by that particular number, sorry, so you get 7 as the answer. What table times table will help you? Think about 5 times table. In 5 times table, 5 times 7 is 35. So 35 divided by 5 is 7. And again, what we have here as 5 should be also there in the numerator. So it is 5 over here. Now 15 divided by 5, the answer is 3. I hope this is clear how we have worked it out. So 3 over 7 is the equivalent fraction to 15 over 35. I hope you have understood why we have used these division signs here. Why? Because here we were supposed to move from 15 over 35, we were changing to something over 7, right? So this particular something needs to be such that it makes the number smaller. From 35 we are getting to a smaller number, that is 7, right? So we need to divide both the numerator and denominator by a number which makes the given number smaller. Okay, I hope this is clear. Now let us move ahead and work some more equivalent fractions. What we have learned so far is the method of multiplication and division of a fraction in order to get the equivalent fractions. Now what we are going to learn is we are learning a very interesting fact about these equivalent fractions. Let us see what these facts are. Look here in this particular table in front of you. What we are going to do now here is we are going to first read the first box which says equivalent fractions. So we already know that 1 over 3 and 3 over 9, they are equivalent. Okay, this is a fun fact about your equivalent fractions, and this is surely going to help you to calculate your equivalent fractions further in the lesson. So the first box says product of the numerator of the first fraction and denominator of the second fraction. So here in the first fraction we have got 1 over 3 and we have got 3 over 9, right? So we are going to take the product of the numerator from the first fraction, that is 1, and we are going to multiply it with the denominator of the second fraction. So that is 1 multiplied by 9. What is the answer? It is 9. Now look at the next one. It says product of the second denominator, the product of the denominator of the first fraction and the numerator of the second. So that means 3 times by 3. What is the answer? 9. Are the products same? Yes. Okay. Look at the second one. Here we have got in the numerator of the first one it is 4 and the denominator of the other one is 35. So 4 times 35, the answer is 140, right? Now moving on to the next one. It is 4, we have done 4 times 35. So here it will be 5 times 28. And what is 5 times 28? 5 times 28 is again 140. So do you see that the answers are still equal? Moving to the next one. What is 2 times 15? It is 30. And what is 3 times 10? It is 30. Again they are equal, right? The last one. What is 1 times 16? It is 16. What is 4 times 4? It is 16. So again the answer comes out to be yes. Do you see what we are doing here? Basically, let's just do this again here. Here, first we'll, let's just put another blank slide so that we can just discuss this more here. Let us discuss what we just learned even more. So here, say you have got 3 over 4. Okay. Let us think about an equivalent fraction to 3 over 4. So let's just times both these fractions by 2. The answer is 6 over 8. So we know that 3 over 4 and 6 over 8, these are equivalent fractions. So now look a fun fact to this. 3 over 4 and 6 over 8. We are just discussing what we have just discussed in this particular table. Okay. What we are doing? We are going to multiply the numerator and the denominator here and this numerator and denominator here. Okay. So what is the answer? If you multiply 3 by 8, it is 24. If you multiply 6 and 4, 24. Do you see both the sides the answer is same? Say you have got a fraction 1 over 5. Okay. And you have got a fraction 5 over 25. How can I check whether they are equivalent? What you can do? Just multiply like this. Cross the multiplication. So what is 1 times 25? It is 25. What is 5 times 5? It is 25. So yes, the fraction is equivalent. Let me give you another example. Say now you have got 4 over 28. Okay. And let me give you a fraction. So it is 1 over 7. What are we supposed to do? We are going to do the cross of the multiplication. We are going to check whether this particular fraction is equivalent or not. So what is 28 times 1? It is 28. What is 7 times 4? So do you think the fractions are equal? Yes. Okay, so this is another method to check whether the given fraction is equivalent or not. We learned how to make equivalent fractions. Now we have learned how to check whether the given fractions are equivalent or not. Now let's do a question. It says that find the equivalent fraction of 2 over 9 with denominator 63. So we are going to use those boxes in order to think. Now the first thing that you should think is that, are you getting bigger Or are you getting smaller when you go from 9 to 63? Are you getting bigger or are you getting smaller when you go from 9 to 63? The answer is you are getting bigger, right? So when you are getting bigger, would you think about multiplying or dividing? You multiply. So what are we going to multiply 2 and 9 with? Think about your 9 times table. 9 times what number will give you 63? 9 times what number will give you 63? I hope you know the answer is 9 times 7 is 63. What we do with the denominator, we'll do the same with the numerator. So it is also 7. And the answer that comes out is 14 over 63. So this is the equivalent fraction to 2 over 9 with the denominator 63. I hope that you have understood well that how you need to work with the questions with a certain condition given to you. Okay. So here the condition was to make the denominator 63. Say if I say that what is the equivalent fraction to 2 over 9 such that you get 4 as the numerator. Then are we getting bigger or smaller? We are getting bigger. So we need to multiply. With what number do you think we should multiply 2 in order to get 4? It is 2. So we do the same with the denominator and 9 times 2 is 18. Okay, so this is how you need to work with the questions with the certain conditions given to you. Moving forward here, it says the simplest form of a fraction. We have worked with the equivalent fractions. I hope it's clear. Now we are going to do the simplest form of a given fraction. The simplest form, as the word says itself, we are going to break our fraction such that it cannot be simplified further. Okay, that will be the simplest form. If the number and the denominator do not have any other common factor than 1, then it is said to be the simplest or the lowest form of the fraction. Let us understand this with the help of the example. It says reduce the fraction. Reduce. How can we reduce something? If we divide something, then we reduce it. Okay. If we multiply something, we increase it. So here we need to reduce the fraction, that is 18 over 27 to its simplest form. Let us see how we can do this. Think of a number with which you can divide the numerator and the denominator both, because we know that here we should have same number, right? So I think both of these numbers are there in a 3 times table. Am I right? So here what answer comes? So 3 goes into 18 how many times? 6 times. 3 goes into 27 how many times? 9 times. Now what comes out is 6 over 9. Do you think this is the simplest form? No. We can further divide it. With what number can be further divided? I can again divide it by 3. How many times 3 goes into 6? It goes 2 times. How many times 3 goes into 9? It goes 3 times. So this comes out to be the simplest form of the given fraction, that is 18 over 27. I hope this is clear. Now it says let's learn the shortest method to do this. Here do you see that we have chosen, first we have divided it by 3 and then again we divided it by 3. So it is like we are taking multiple steps. Let us learn a method where we can directly get from the biggest number to the smallest number. It says you find the equivalent fraction, which is the simplest form. We just have to find the HCF of the numerator and the denominator and simply divide the both by the HCF. For example, say again let's take 18 over 27. So what is the HCF of 18 and 27? Let's do the formal way. Here we have 18, here we have 27. Both of them goes in 3. So here comes 6, here comes 9. Both of them goes in 3. Here comes 2, here comes 3. And further we cannot divide them, right? So what number comes? It comes 3 times 3. So what is the highest common factor? The HCF of 18 and 27 is 9. That means we are going to divide the numerator and denominator by 9. So we get the answer as 2 over 3, which is our simplest form. Okay, so here we have used the shortest method to get to the simplest form of equivalent fraction.